Okay, so this is number 17 on the 10B. So we have a race between those snails, 5 snails, and there is at most one tie. So let's highlight that part. So it says at most one tie, which means we may not have a tie at all. So, but the tie can involve any number of snails. So we can have two like snails or 5 snails all tied. For example, the result of the race might be like be, like D is the first, like I'm gonna use that initials, and A, C, and E tie for the second, so which is 3 like snails. That's already 4 left. 4 is over. And the fifth one will be the B, so which is basically a third one, but anyway, so fifth. So how many different results of this race possible? So the like you can just go with the cases based on the number of snails that will actually like be tied. So like if I say zero like zero tie, okay, so then all 5 like snails will have different like rankings. So that could be done like 5 factorial ways because 5 times like 5 is the first choice, like for the winner, and then 4 is the second, so and stuff like that. So that's 5 factorial ways. But if you have like one snail tie, um I mean, not one, actually 2 snail, because one cannot be. So if I have 2 snails, will be tied, right? So you can do this like couple ways. Like, how do you do that? Like, you just need to know what 2 snails first, right? So you can choose 2 of those 5 to determine what 2 snails will be tied. And as soon as you determine that, like you can just say, okay, it's tied, but is it first place or second place or fifth place or whatever? So like you can just do that, or you can say, okay, so as soon as I have 2 snails tied, I let me take the other 4 like ranking. So there is like other 4 spot we need to arrange. So like and not other 4, there is 3 other snails, but if you take the snails that's tied, that's in another group. So that's basically a total of like 4 snails because you take those 2 as a group. So when you have 4 things together, so you can just have them 4 factorial ways to arrange them. So I hope that was clear. So, and if I have like 3 snails tie, so then you just need to choose 3 snails first. Just imagine those 3 snails like this. Let's say S1, S2, S3. So this is a group of 3. And then we have, let's say, another of 1 and then S5. So this is one group, and then this is 2. This is now 3. So we just need to arrange this. Like, is it in the first spot? This is second, this is third, or this is first, this is second, this is third. So how many ways can we do this like raise? So that's 3 things. So that should be 3 factorial ways. So that's why this was 4 factorial, because we took the first 2, for example, and together, and then we got these 2, 1, this is 2, 3, and 4. And if I have like 4 snails tie, then you just need to choose what 4. Okay, so then as soon as you do that, so you have 1 more left. And then with this group and then 1 more left, so you have 2 ways to arrange it, because either this group will be in the first like place, and then the last one will be first, or the other way around. So if I have all 5 snails will be tied, so there's only one way to do that, right? So that is the 5 choose 5, another way of saying. But as soon as you choose all 5, so they are going to be just determined. So there's one way to arrange it. So if I count those, we got 120. And then this is 5 choose 2, which is 10. And 4 factorial is 24. And then 5 choose 3, same as 5 choose 2, which is also 10. And 6 will be 3 factorial. So 5 choose 4 is the same as 5 choose 1, which is 5. And then times 2, and then plus 1. So that's 240. That's 120, which is 360. And then 60 will be 420. We already passed through these. And then 10, that's 430, 31. So that is the choice D. So it was like not really challenging problem in my opinion. So it was just a bit careful thinking about these rays. So this is one of the problem that I seen a lot in the old like problems anyway. So this wasn't unexpected. Anyway, so I'll see you in the next video.